Today, we're going to be talking about the wonderful, wonderful world of monorepos. Yes, fantastic. So, monorepos. What is a monorepo? Do you want a monorepo? Why shouldn't you want a monorepo? Do they taste good? We'll discuss these questions and more coming up. But first, a brief history of version control. So, version control has evolved over the last few decades, but the very first version control system we all probably used are files. Now, you might be thinking, Marcel, you idiot, files aren't a version control system, but you'd be wrong, and here's how. When I was but a young child, and I made my websites for GeoCities, my file versioning system worked like this. I'd have a website called website.html, and sometimes I'd get to a point where I tried something new that was really tricky, but I wouldn't know whether I could go back if I broke it. So I did a clever thing. I did Control-C, Control-V, and I made a new website file called website_tryingstuff.html. Now, if I made it go bad, I always had a safe point to go back to. This is a very rudimentary version of a commit. So we have this ability to now have save points in our effort. And this means that we can empower ourselves to make more changes and take more risks than we could otherwise normally do if we just had one file that we couldn't go back on. And there was even a very, very basic collaboration aspect, because sometimes I would give my website on a USB stick to my friend Sarah, and she would make changes and then send them back to me over AOL Instant Messenger, because it was the 90s. And her changes would be under website_sarah.html, and then I would hand merge them using my eyes like an idiot. So we eventually got quite advanced and said, well, why don't you put your name and the time you put your changes in? That way we can put the right order of changes together. So while version controls have evolved a lot since file naming days, there are two key points that haven't changed as we progress through time, which is all new version control systems try to empower change. They make you feel safe about putting new changes into your software and going back if something goes wrong, and they facilitate collaboration. They help more people more easily collaborate on one software project. We've gone from files to CVS if you're born in the 90s, to SVN if you're born in the late 90s, and Git if you're born in 2000 or later. And now we've got to figure out what we want to do next. Or is what we've currently got good enough? Well, let's have a look at these two core tenets of good version control systems. We want to empower change. We want to make people be able to try new things, put new features into their project without hesitation, with confidence, with speed. And we also want to facilitate collaboration. We want to be able to bring people in very, very quickly. We want people to feel like they can contribute and have all their changes merged in without problem. So in trying to figure out how to rate a new version control system or new version control system process, I kind of made these bullet points that dictate how we could measure the goodness of such a thing. So how easy is it to get started? If you have something that's very easy to get started in, then it's got good collaboration. Is it easy to submit changes, test and deploy? Well, then you can put changes in easily. And is it easy to identify faults? So if you can figure out exactly where and which commit caused the error in production, you can then figure out how to undo it. And this empowers change, because if you can save yourself from yourself, you're much happier. So at the moment, the norm is perhaps to have a bunch of Git repositories across multiple repositories, right? But why do we put all of our projects in multiple repositories? And to set the stage for a bit of a language politics, we're going to define some terms. So mono means one, poly means many, and repo means repo. So I propose that we call the situation where everything's in one repo a monorepo, and a situation where there are many repos for one single project a polyrepo. Right, cool. I've branded this. Let's go. So often you'll find a standard React project might be laid out like this. You have 3 separate repositories, one for your GraphQL layer, one for your React layer, and maybe a different one for your docs. And there's a good reason that we take this approach in our software project today. It's not without its positives. If you take the resolution of this screen is different from what I expected it to be. That's cool. We're going to end up more on this side of the screen. So if you take this polyrepo approach, we have a flexibility that we can utilize, which is each repository can have its own processes, its own conventions, and you can also encapsulate complexity, right? So you have this ability to cordon off all the security bits. Maybe all the CSS is here and all the database stuff is here, and you don't have to know about the ones because you just have to know about the interface between them. You also have this idea of things being easier to deploy and to scale. So if you have something that's just a simple repository, it can feel like it's much easier to put that through a Jenkins pipeline and into the universe. And if you need to make more of them and horizontally scale, you just increase an integer somewhere. And lastly, polyrepos really lend themselves to clear ownership and the politics of an organization. Often, if you have a very large organization, you're going to have a situation where if there's a team that you want to contribute to, but now you have to go talk to a manager and go to a meeting and have a discussion, and someone wants to make sure this happens or that happens, but if your team gets its own repository, then you can do whatever you want. And so another repository is born. But polyrepo approaches do have the negatives as well. Let's consider those key tenets we thought about earlier. If you have a polyrepo, you have a scattered development environment. You have someone new join your team, okay, that's great. You want to get production running on their laptop, right? We'll download these 4 different repositories, figure out 4 different terminal panes, start them all in the right order, and then maybe you can have the product run on your machine. You have a complex lint build, test, and release process, because now if you want to, say, change a linting rule, you have to change it in 4 different repositories. Building has to be done in the right order, and releasing, while in each separate project is fine, you still have to release everything as one eventually. So your 4 pipelines have to talk to each other coherently eventually. You also have to do cross-repo changes and rollbacks, which means if you have a feature that touches, say, the documentation, the API, and your React web app, you now have 3 PRs to manage. If you put those features in, approve them, and push them in production, and something breaks, you have to figure out exactly which repo broke, why, and which ones to roll back. You have to also figure out how to enforce conventions across repositories, because otherwise you have a lot of context loss about this repository uses, say, class-based React components, and this one uses stateless functional ones, which is fine and offers flexibility, but the context switching overhead means that you will lose time in development, and bugs are much more likely to sneak in. So given these potential points of improvements, what's next? Now, you'll probably be completely unamazed to find that I think monorepos might be next, given that's the title of your talk. So we're going to discuss briefly what is a monorepo, why would you want one, is it suitable for your team, how would you get one, and will Twitter think you're cool if you have one? I'm going to answer the last question straight away. Don't worry what Twitter thinks about you. I'll think you're cool, and that's enough. OK, so what actually is a monorepo? You can always write in all caps and seem like a badass. A monorepo is simply a repository that contains multiple packages or projects. They don't actually have to be related, but they can be, and it's a very broad term. And monorepos really come in 3 distinct flavors. Most of us know colossal monorepos, but there are also project monorepos and micro-platforms. So let's talk about the monorepo type that you're probably most well aware of, colossal monorepos. So, colossal monorepos, these are the things that are at Google and Twitter and Facebook. Google has an 86 terabyte plus sized monorepo. It would never fit on anyone's laptop. They have custom source control technology to deal with the scale and the complexity of this beast. And just the sheer amount of PRs pouring into their project continuously. It is a highly intimidating thing to think about. And if this is the only thing you've ever heard about monorepos, then I can completely understand why you might be thinking, monorepos aren't for me. OK, we're not going to talk about colossal monorepos anymore. They don't affect us. If you do work at Google or Facebook or Twitter and have to use a monorepo, a team takes care of that for you. And if you're on that team, this is a very junior talk for you. So thank you for coming anyway. Project monorepos. You've almost certainly interacted with one of these, because React is the project monorepo, Symfony, Babel, Jest, Meteor, they're everywhere. And it basically means that all the modules that define that functionality are in one place. They're versioned centrally, which means that if you do any changes to the monorepo, all the packages get updated. And the dependencies are managed both internally and externally, which we'll go into later. Here's an example. This is Babel with a little bit of truncation. It has over 100 packages inside it, 100. At the very top, there is a top-level package JSON with a learner JSON. We'll talk more about the learner JSON later. And here's where the actual application code lives. So this is where all like little transforms and language features exist. And there's over 100 of them. And each one of them is a independent NPM package that gets processed and published through the single monorepo. Now, let's assume you are Seb McKenzie, and you want to change a linting rule. Say you want to go from, or a syntax rule. Let's say you want to go from single to double quotes. Imagine if each one of these packages was its own NPM repository. There'd be over 100 NPM repositories to change the code in, submit a PR request, review the PR request, and then release, and then have to make sure that these are all in sync all the time. That's going to be one really unhappy intern, I assure you. So, monorepos for packages makes a lot of sense. And then there's microplatforms, which is the kind of monorepo I'm personally happiest with, and the one that's given me the most benefit, which is your entire application stack in one repository. So instead of having like your GraphQL endpoint and your web code and your React Native code and your shared components and your documents in different repositories, you have them all in the same repository, which is you can test, build, and deploy them together. Here's what a mock version of it might look like. So you have your API code in this little block here. You have your shared components here. And, ooh, you skipped one too far, didn't you? Yeah. Come on, I believe in you. Wow, okay. Temperamental. Does somebody have a Bluetooth device that's kind of excited to be here? Because I think that might be interfering with the clicker. That's fine. So here we go. So we have all our apps here for our web app and our iOS app. That's all good. We have our API and our components and everything all in one repo, right? So, okay, that's great. Stuff is in one place. But why should we use a monorepo? Well, everything is in one place. And we've gone through the process of putting things that are disparate into one location before, and what's called JSX. For those of you that remember the early days of React, the amount of kicking and screaming and vitriol and strange threats over Twitter you'd get for saying JSX might be a good idea was obscene. Because there had been so many years we had the church, the dogmatic approach that separation of concerns means separation by type of thing. You put all your JavaScript over here, and all your CSS over here, and all your HTML over here, and the world is good. You'd be a good software engineer. And then somebody said, hey, why don't we group stuff together by functionality? Wouldn't that be great? Things to do with like components where features live, so you put your HTML and your JavaScript kind of together, and people lost their minds. But that's okay. Now we're to the point where we're putting CSS in the same place, because it turns out having this kind of co-location has its own benefits. So, with this in mind, let's have a think about what kind of benefits we get by putting all of our code into one single repository. The developer environment. No longer do you have to check out 4 different repos, make sure the environment variables are correct in each terminal window, and do 4 different yarn starts. Now you can do yarn at a top level, get all your packages installed at once, hit yarn start, your project starts, all in one terminal window. What you've done here is made it much easier to get involved in your project, and therefore you've facilitated collaboration. Yes. You also have a common configuration. So we briefly touched on this in the Babel saga, but if you have a common configuration at top level, it's much easier to lint or apply prettier or change your Babel rules for your entire stack at once, which means that there's a coherent convention all the way through. And also, you never forget about a package, because what happens when someone says, someone should go through all our repos and make sure we now use double quotes instead of single quotes, is that one package that was last updated 6 months ago, no one remembers until 2 years later when someone has to update it, and then it's 2 years behind, and some poor intern is going to spend a lot of time trying to get it to look modern. You also get a bit more code reuse. So it's, of course, completely possible to use NPM to have a separate repository where you can stick your shared components, right? But then you have to pull them down. If you have a web application that requires a shared component library, but you have to update a shared component library first, now you've got to update this, push this into the cloud, into NPM, re-download it over here, and make sure this hasn't broken anything now. And you can kind of cheat the system using npm link, but it's a real headache. And this way, you can much more easily split things down into packages that live in the same repository, and you can like, get that sweet reuse much more easily. And this is perhaps the best thing about running a project as a monorepo. You get cross-project changes. You have one PR for multi-module features. You have one PR to review full context, and one PR to revert if something goes wrong. Let's take an example from Expo. Expo loves their monorepo. They keep writing blog posts about it, and I don't blame them. So Expo, for those of you who don't know, is a React Native tool that gives you a bunch of good stuff to essentially preview and ship your React Native applications around the world. Because they are a React Native platform, they touch Android code, iOS code, React core code, and a lot of documentation. So in their story, they have a single repository called Universe, which is super cute. And if they want to write a new feature that touches all the mobile platforms and the documentation, they have to do a Git branch. In the same Git branch, they write the Android code, the iOS code, the documentation, and then they do a single pull request, which is then reviewed, which has all of the changes for that feature in one place, which is great, because now when the person reviews the documentation, they can see if that documentation actually matches the API changes. Otherwise, if you have a PR for the documentation and a PR for the API, you'll never know if these two are actually in some way coherent. And then a single PR is merged into the repo, and everything is great. This really empowers change because it lets you move more confidently throughout your code base and through your feature base. And of course, if this goes wrong, there's only one thing to undo. And as you revert that PR, not only do you take the feature away from whatever it is that went wrong, you also take it away from documentation, which seems right. You also have a single release process. So we said before that continuous deployment and integration might seem easy with single repositories with only one technology inside it. But we do still need to build everything eventually, and at some point we need to test across these interfaces. So this is usually done with end-to-end tests or maybe some staging environment, but that actually is its own level of harsh complexity, which is hidden by having a polyrepo approach, but does need to be tackled. And as stated before, like now we can release and revert with confidence because we just released the entire repository as one immutable block. And something I think that's not really talked about enough with the monorepo approach is we have a single culture as a result. Software is easy, people are hard. The hardest thing about software has always been people. If you split people up into small tribes where one set of people works in the CSS and one set of people works on the database side, for example, often it can feel quite alienating and tribalistic, which results in people perhaps not respecting the work of others as much or not knowing what they contribute. And by having a single repository, it's easy to see what other people do and how you can benefit from each other. It gives you a broader, singular culture to benefit from. OK, so monorepos, unified developer environment, yeah, single test build release, cross-module changes, cross-module rollbacks, code reuse, and a shared culture. All of these things empower change and facilitate collaboration, which is great. It seems like we're heading on the up and up. But if they are so universally positive, why aren't monorepos everywhere? And of course, there are things that you have to consider before you embrace a monorepo. The first thing to consider is your repository will be bigger. Now, you won't have Google problems. Your repository won't be 86 terabytes big. And it'll almost certainly not be so big to cause you a problem. That being said, if you have developers who work in, for example, low-income nations and don't have nearly as much hardware as, say, like someone who works on Netflix and is doused in MacBooks, it might be something to consider. Continuous delivery and deployment is going to be more challenging up front rather than later. So this requires effort and uptake by people inside the team. The tooling is less mature. Come back. The tooling is less mature. Fewer tools have a monorepo in mind. This is getting better very quickly, but you may have to do a bit of finagling here and there. The community resources aren't nearly as vast. You can't Stack Overflow your way out of every post. You may have to have a slightly better understanding of the processes that define your code. And I think the key consideration is that your organization may not be able to accommodate one. I always circle back around to this, but people are the hardest part of software. And at the beginning, we had this scenario where you're in a big evil megacorp and you have your own repository because you don't want to deal with the bureaucracy of dealing with someone else's. To have a monorepo, you have to have a team that you trust with a large amount of autonomy where everyone can contribute, review, and have a soft amount of ownership of the entire code base. And if you have an organization that's dramatic and very hierarchical, that can be very, very difficult because it becomes a management nightmare. Okay, so these are the challenges we're going to face if we want to take on a monorepo. And you've looked at them and maybe go like, okay, I understand that there are risks and I understand there are challenges, but I'm still interested. I want to try. And you go, all right, how? How do I get monorepo? Well, these are the core challenges of getting a monorepo into your project today, or putting your project inside a monorepo. How do we manage the dependencies inside a monorepo, both internal and external? So inside your monorepo packages, some of those packages will depend on each other. How do we version test and build a whole repository at once? And how do we continually integrate and deploy that repository? We're going to focus entirely on JavaScript for this, because it's a React conference, and I don't think we're quite doing everything in ReasonML yet, but luckily we're no longer doing things in TypeScript. That's been deprecated, thank God. So the focus on JavaScript means that I can now give you explicit help and tools to get you on your way. So if you're in React land, you've probably heard of Yarn, and Yarn has a feature called Workspaces. Workspaces let you manage your dependencies in a monorepo style succinctly and does most of the heavy lifting for you. It manages your dependencies, it eliminates redundancies, it exposes your code packages to each other, and it gives you that sweet, sweet top-level Yarn install. So you have to do Yarn install once for everything in your application, and then Yarn start. So what does this actually look like in practice? This is Jest, the current most popular testing library / framework / runner. And here is a sample of what the Jest monorepo looks like pre-Yarn workspaces. So we can see there's a top-level package JSON and a node modules on top level as well. And then there's some packages. You've got Jest matcher utils and Jest diff, and they also have dependencies, right? And you can see some of them are actually very common. So you see chalk in 3 different places. And chalk is a tool that colors your terminal, so you find it everywhere. And you can see there's a lot of redundancy here. And also, that at the bottom, Jest diff requires Jest matcher utils. And OK, so it goes to like the up1 relationship to get that, and that's OK. But as soon as you get into deeper nesting, you can see how this gets very complicated very quickly. So you've got these commonalities. We've got some redundancies and some complexity. After workspaces, you can see what's happened is all the packages are now very, very slim, and all the common bits have been lifted out into a top-level node modules, which means there's no redundancy, and we have managed the complexity of our inter-package dependencies. Great. So, all right. Got that one squared away. Versioning, building, and testing a whole repo, we're going to do with Learner, which has the most metal logo I've seen in years. So Learner is a tool for managing monorepos, unsurprisingly. It's often used with Yarn workspaces, and it's probably used by all the packages you know. So Babel uses it, React uses it, Jest uses it. Learner maintains this one single web page where they put down all their users, and it is obscenely long at this point. It is being battle tested to the extreme. So Learner manages your testing, versioning, building, and releasing with a little bit of help from you. Let's take an example, Learner, React, and Webpack project. So what we've got here is we've got 3 packages where only one is actually displayed to the end user, right? So you've got Orchestra, which is the bit, the React application that actually sits on a server and gets served to a client. And then we've got Leaf and Async Leaf, which are just packages that Orchestra relies on, right? And one of them is even async loaded, because we like to make our life hard for ourselves. So we've got to think about the process here. We've got 3 packages, but only one's actually released. But we need to build all of them, because they're all JavaScript, and they also be put through Webpack. OK, let's begin. So at the top, we have this learner JSON file, which you might think is where all the magic happens, but it's not. Learner JSON is really easy, because it gives you the version of learner, where the packages live, what kind of client we want to use, whether we want to use inbuilt workspaces, yeah, of course, and whether we want to have fixed or incremental versions. The real magic is actually in package JSON. So as you can see, this is a real project because it's full of cruft. And this is where all the magic happens. So our process is we want to lint all of code inside our monorepo. We want to test all our code to make sure our logic is good. We want to be able to build each one of our packages in the right order. And we want to webpack them all together. And then we want to push them out to the universe or into our continuous integration, right? OK, cool. Linting. Easy in a monorepo. We just go lint everything in every package that has a source. Great. Testing. Jest is very good at... You are very, very precocious today. OK, so Jest luckily has an AST that sucks up all your code and figures out where your changes are for you, so that's super easy. And this is the meat of the work. We have a build Babel and a build Webpack step. And build Babel calls learner exec parallel, which basically means, hey, learner, go to all these different sub-packages and do a parallel build and put all of those into the right lib directory. Then, webpack them all into one big bundle. What learner does for you here is it manages the dependencies between each package and also executing them into each one for you rather than you having to write some really complex bash script. Now finally, in the release, no. Oh, wow, OK. I think I might stick to clicking on a laptop. Sorry, folks. Thank you for your patience. All right, so release, we do the linting, we do the building, and then we publish. Line of publish essentially increments your entire monorepo version and kicks out an artifact for you. All right, we got 2 ticks. Exciting. We've got manage dependencies, versioning, testing, and building whole repo. Now, what about continuous integration and deployment? This is the bit that scares people the most, and I can see why, because if you have several different technologies that have to then be deployed to different places in the universe or through one pipeline, that seems very complex. But actually, it's not that bad. However, these are the concerns that people do have. And there are other things to consider as well, like if you have a large monorepo that has a long test cycle with lots of end-to-end testing and you have lots of commits, do you now get to the point where your containers are always on fire trying to facilitate this? Nowadays, there are lots of CIs that happily accommodate monorepo work. Cell CI is probably my favorite. It has a cute logo. But the reason it can accommodate monorepo work is actually very simple, and you can put this into any continuous integration platform. What Cell CI has, as you can see in this YAML file, is this clause that is labeled when. And that essentially says, only do this task if there was a change in this package or any other pattern you want to write. And it turns out this is actually very, very easy to put into any continuous deployment/integration platform. You can put it into Jenkins, Travis, Circle, and there's essentially a one-line bash script that says, hey, do a git diff, find all the packages that changed, and just run those. I was very intimidated by trying to figure this out in my early days, but it turns out actually pretty easy. Fab. OK. So we have all these things ticked off, which means we could now think about how we would go about creating a monorepo. But you might be asking, how do you incrementally migrate to a monorepo because you already have a project that you want to make less complex by sticking inside a monorepo? I'm going to very, very glibly say, copy your current code, put a folder called packages, and paste it in, and you're on the way to a monorepo. It is surprisingly easy. And then, of course, you have to make your changes to continuous deployment. But you might be saying, Marcel, that's great, but I also want to keep my commit history. It's like, oh, OK, that's fair. Learner has an import tool that helps you. But essentially what you're doing is just copying code and its history. So if you're comfortable with Git, you can also just use Git tools to do so. Things like Git subtree add or remote and rebase. And if you want a nice little GUI, there are tools like Shopsys that will help you out. OK, here's the key question. Should your team get a monorepo? The answer is, probably. I've seen monorepos increase in popularity over the years. I've not seen any team go back from a monorepo. And the tools continue to get better. And I think it's important that we continue to push ourselves to do better work in managing the complexity of modern software. Software will become more and more critical to our lives as time continues on. The importance of our software being good and the impact it has on people will also continue to increase. So we should always be pushing ourselves to do things better and include more people for having the ability to facilitate more collaboration and empowering each individual person to do change. So, any team that takes on the mantle of empowering people to change and add to their software and facilitates collaboration more will always be more competitive than ones that don't. So, be a Bastion, be a Vanguard, try MonoRepos today. Thank you very much.